Hello and welcome to my channel called Math is Hard. Today's video will be about breadth first search algorithm, also known as BFS. BFS is an algorithm for searching a graph. BFS starts at some node of a graph. First, explores the neighbor nodes and then move to the next level neighbors. First we construct a table that contains the columns Q, W, which specifies which node we are discussing, and E, which is the edge. So let's start, for example, in this node. We mark the node as 1. And we add this node to the queue. We are discussing node 1, so we add 1 also in second column. Now we ask, is there any unmarked edge and node I can get from node 1 in one step? Yes, I choose for example this one and mark this node as node 2. In column E, I add edge 1, 2, and mark this edge in graph. Now I add node 2 in queue. But I still have node 1 like the one I'm discussing. So I asked again, is there any unmarked edge and node I can get from node 1 in one step? Yes, for example this one. I mark this node as node 3 and add edge 1, 3 to column E. I also mark this edge in graph. Now I add node 3 in queue. But I still have node 1 like the one I'm discussing. So I asked again, is there any unmarked edge and node I can get from node 1 in one step? Yes, the last one. I mark this node as node 4 and add edge 1, 4 to column E. I also mark this edge in graph. I add node 4 in queue. And I'm still discussing node 1. But there isn't any unmarked edge and node I can get to in one step. So, now I remove node 1 from queue. I'm discussing the first node in queue, it's 2. And I ask, is there any unmarked edge and node I can get from node 2 in one step? Yes, so I mark this one as node 5 and add edge 2, 5 to column E. I mark this edge in graph. And I add node 5 to queue. The first one in queue is 2, so I'm discussing node 2. From node 2, I can get to this node. This node is node 6. I add edge 2, 6 to the column E and mark this edge also in graph. I add node 6 to queue. I'm still discussing the first node in queue, it's 2. But there isn't any unmarked edge and node I can get from node 2 in one step. So I remove node 2 from queue. In queue I have now nodes 3, 4, 5, and 6. Node 3 is first in queue, so I write it also in second column. And now I ask, is there any unmarked edge and node I can get from node 3 in one step? Yes, edge 3, 4 is not marked. So I add this edge to column E. And I also mark this edge in graph. Node 4 is already in queue, so I'm not adding anything to queue. I'm still discussing node 3. From node 3, I can get to next node, which I mark as node 7. I add edge 3, 7 to the column E and mark this edge also in graph. I add node 7 to Q. First is still node 3, but all edges coming from node 3 is marked. So I remove node 3 from Q. I'm discussing the first node in Q, it's 4. And I ask, is there any unmarked edge and node I can get from node 4 in one step? Yes, edge 4, 7 is not marked. So I add this edge to column E. And I mark this edge in graph. Node 7 is already in Q, so I'm not adding anything to Q. I'm still discussing node 4. Is there any unmarked edge and node I can get from node 4 in one step? Yes, so I mark this one as node 8 and add edge 4, 8 to column E. I mark this edge in graph. And I add node 8 to Q. I'm still discussing the first node in Q, it's 4. But there isn't any unmarked edge and node I can get from node 4 in one step. So I remove node 4 from Q. From node 5 I can get to node 6 and this edge is not marked yet. So I add this edge to column E and mark this edge. To Q I'm not adding anything, because node 6 is already here. From node 5 I can also get to this node. I mark this node as node 9 and add to Q. All edges coming from node 5 is marked. So I remove node 5 from Q. From node 6 is still one edge which is not marked. It's edge 6, 9. Now all edges coming from node 6 is marked. So I remove node 6 from Q. All edges coming from node 7 is also marked. So I remove node 7 from Q. And it will be the same for the last two nodes. We don't have anything in Q, so our algorithm ends. This algorithm time complexity is as order n squared. Thank you for watching. If you like the video, please like and subscribe.